Greetings and welcome to Make Programming Fun Again. This is the second video in my Bitcoin online store series. Today we started this series by initializing a project and setting up things like Tailwind CSS, the router, SQL-C, and automatic recompilation. If you are new to this project, you can just clone it from my GitHub. The repository is at Kinu at github.com/moros/Kinu. Kinu means silk in Japanese and Michi means road. And this is named after a website that was an early adopter of Bitcoin. And in this video, I'm going to show you how to implement real-time exchange rate updates. And the reason we need exchange rates is because most stores need to know the exchange rates between fiat currencies and between Bitcoin or any other coins or tokens that you are selling for. And there are two reasons why you may need those exchange rates. One is because you are actually pricing your products or services in a fiat currency, and you need to be able to calculate the approximate amount in Bitcoin or your cryptocurrency of choice. And another possible reason is that you may actually, even if you actually price your services in a cryptocurrency, you may need to be able to show it to calculate an approximate value in a fiat currency. For example, if you sell something for Bitcoin, people will still want to know how much they need to spend. And there are two ways you can fetch these exchange rates in an application, even with like reasonably real-time applications. You could either listen on a WebSocket client if you really want hard real-time updates from an API, or you could just poll the API, the REST API, every 5 seconds or so. Most APIs should be able to handle 5-second poll intervals. Now I'm going to try and show you both. And we could probably just keep both approaches in an application, but realistically, if your application is not going to be used a lot, it's going to be much cheaper to just use a REST API and only poll it when it's necessary. So I'm going to start with a WebSocket because it's more difficult. And I'm going to try and implement like a global state. And I'm first going to implement it in a separate like experimental package. And then we're going to try and somehow integrate it into the application. And I don't know if it's not going to be too much for one video, but let's try. So, okay, I chose an API called coinapi.io, and I've looked at a few options, and there was one called Bitvavo, and they seem to have like a more reasonable free tier for their API, but at the same time they are EU-centric, which means they are extremely bureaucratic, and I would need to they want to know a billion things about me before I can even use the free tier, and they have KYC, and they required me to receive a confirmation message on a European number, which I didn't have access to at the time because I live in Taiwan. And you know, I am an EU citizen, but I know a lot of my viewers aren't. So I chose this Coin API because the only thing they care about is that you have an email address and that you add a payment method. And so actually, yes, in this Coin API application, they actually give you a free tier of $25 in free credits, and that should be enough for like a month of infrequent real-time updates. but you need to add a payment method. So they don't even charge this payment method. I only added a virtual card from Revolut, and you can probably do the same thing. And then I generated an API key, and you have to. I chose not to give it access to all endpoints, and I only chose the exchange rates API, and then I created this API key, and like so, and then they display an API key in here, and you can just copy to your application and paste into your .envrc file. So copy.envrc.sample.envrc. So if you open this envrc.sample, it's a basic file that I wrote today, and we're going to source all these environment variables into our working session to be able to access these variables in our Go application. And I'm going to paste this API key here, and I'm going to also turn focus mode. And yes, and then I run drenv allow, and then I can access this coin API key in the terminal, and I will be able. This also means I'm going to be able to read it in the application. And in order to be able to use it everywhere, I'm going to define a new package. I'm going to call it config, and I'm going to implement a helper function called must_getEnv, and it's going to accept a key, which is a string, and this is going to be the name of the environment variable, and it's going to return a string. And then we're going to fetch this value from the environment using os.getEnv with the name of the key. If this value is an empty string, meaning that the environment variable is not set or is empty, then we're going to abort the program saying fatal environment variable with this name is not set, and we have to pass the name, and then we return the value instead. And then we can use this. You can use this helper method in other places. I'm just going to use it in a new package I'm going to call exchange rates WebSocket, like this. And in here I'm going to create a main.go file, and in it I'm going to create a package main function main. And we're going to need this coin API key, and you can use config must_getEnv coin API key, like so. And for now we can just print it in here to prove that we have fetched it correctly. So I'm going to cd into experimental exchange rates WS and run this script. Okay, and we're getting the coin API token printed to the terminal. Obviously, by the time you are watching this video, this token is going to be revoked, so don't even bother trying to use it. And the next thing we are going to, okay, so now I can just close this tab. And now we can try and figure out how to actually authenticate with this API. So the exchange rates real-time endpoint in here is at this URL. This is a docs.coinapi.io exchange rates API WebSocket endpoints, and the endpoint is here. So this is a constant, so API endpoint like this, and then we are going to need a WebSocket implementation. I'm going to use Gorilla WebSocket. It's a viable WebSocket client and server. So go get-u the URL of this package, and then we can try and see an example of a client. So this is the best implementation they have, actually, more or less. Okay, this is configuration code. We don't care about this one. Now we're going to need a URL, and we do have a URL. So we can just say log printf connecting to API endpoint, and we don't need a new line because log is going to handle it, like so. And then what does it? Okay, I'm going to use to look at the documentation first. So WebSocket. What do we have at WebSocket? Gorilla WebSocket, Coder WebSocket, Exit WebSocket. What is this? Does it mean there is? So it's an XNet. Does this mean that there is now like a native implementation, and we don't need to use Gorilla, or what? Okay. This is looking good, actually. This package currently lacks some features found in an alternative and more actively maintained WebSocket packages. Gorilla WebSocket and Coder WebSocket. What is this one? This is a package imported by 354. This is Gorilla, which is imported by 39,000, and this one is imported by 8,000. So technically it is a bit more more popular than Coder WebSocket, and it may lack some features, but maybe you could just try and see if they're like a reasonable it has at least a reasonable, support for anything. Okay, so what do we have, like a default? Do we have a dialer or what? Dialer. Do we have a default dialer? Do we have examples or what? Examples dial, okay. So WebSocket dial this URL. Okay, dial. Okay. The URL is the API endpoint. And then what's the second? The second argument, protocol. So what is the protocol going to be? WebSocket dial. Okay, so why is this an empty string? I don't know. And then you can indeed just say HTTPS, HTTP localhost, and see what happens. And this is going to return a connection and error if error is not nil. And by the way, how do we even config additional header fields to be sent in the okay, we can use a configuration instead, because we need to pass additional arguments, right? So config is going to be WebSocket config, and what do we have here? Location, and it's going to be actually a URL parse, and okay, URL error equals URL parse API endpoint, like so, because it has to be a parsed URL. So I'm just going to call it endpoint instead. Okay, so this is going to be an endpoint. And then what else? Origin. It's going to be an URL with the scheme of HTTP and host, local host, and maybe path of like this. And then what else? Version TLS config. Headers. So what can we do? Is this like okay, so this is basically a glorified map. So we can say authorization. I think we could pass an authorization header like this, right? We can pass an authorization header with just the token, and this is a map of string slices, a map of strings to string slices. So this is the syntax we're going to use. Okay, we have headers, and this should be enough, I think. Do we need a dialer? Do we need a dialer, or do we not? Okay, I think we can just pass a regular, like pass a, oh well, wait, what? Config dial config. Yeah, I think we'll just see if it works. And okay, so WebSocket dial config. It returns a connection, like so. Log fatal error. And what can we do? How do you read from this connection? Is it like a something that we have to okay, well, okay, we will see. I think we will just write. Okay, so they said that if we want to subscribe, we have to send a message like this. So I'm going to define it as a type, subscribe message struct, and it contains a type which is a string, and it has an annotation of type like this. Then heartbeat is a boolean, JSON heartbeat, and then subscribe filter asset ID. It's a slice of strings, and the JSON key is like this. And then our message to subscribe is going to be JSON Marshall, and we're passing a subscribe message. Yep. Subscribe message with the type of hello. We don't want to pass the heartbeat because it's false by default. And then we pass the pair of Bitcoin to Euro. And then we write to the WebSocket. And yes, let's see. We see if there was an error. If there was an error, if I'm going to wrap it in, if there was an error, log fatal error, and then we can read. By the way, message parameters. I want to limit this because I don't want to accumulate too much in terms of costs, and like this. And this is an integer JSON like this. Okay, I'm going to change it to 5,000 milliseconds or 5 seconds, and then we read from the connection. How do we do it? We Okay, we need to allocate a buffer. Equals make byte slice. I'm going to make it 1 kilobyte large and pass it like this. Okay. And if there was an error, we abort. Let's see if this works at all. Go run. Bot protocol version. What? Okay. Endpoints. Introduction. Okay, WebSocket. So I think we may need to specify like a version. I really don't know the version called WebSocket protocol version. Okay, so what's in this upgrade header? Protocol version. Upgrading to WebSocket. Okay. Protocol. Yeah, but it would be nice if they told us documentation. What do they usually send if it's just what do they send if there is no configuration? I want to see. I'm going to see the actual implementation. Okay, so new config and version is protocol version this. Okay, I'm just going to use this okay, let's see if this works. Okay, we did get something, and I don't know if we actually... Okay, I'm going to fmt println string buffer. Okay, so we did actually get an exchange rate, and let's see if okay, let's see if this was charged on my account. Usage metrics, API keys. It was used 8 seconds ago, but I don't think they actually charged me yet. Okay. Anyway, we know that we can get these messages, and you can just wait. Just wait for those. You can just make a loop, right? So I'm going to write a loop, and outside of this loop, I'm going to create a channel. I think I saw a technique like this in a Gorilla WebSocket or something. Client and server example, yes. I think it was here. So go func defer close down. Okay. I don't think we actually need to pass a heartbeat or anything. Could probably just wait, okay, we want to be able to handle this. So this is what this means is we are going to be waiting for an interrupt message, and then if we're done, how do we know if we are done? Anyway, defer connection close, and then 4. And then where does this done come from? Okay, this done comes if we okay, well, I don't think handling this gracefully is going to matter a lot. We could like write a close message, okay, I guess. Do we need to stop it, or? Yeah, I don't think we have a use case for that for now. So I'm going to use this select statement, and that is a weird name, but it basically means that we are going to be we can't really really select if it's, or can we? Okay, yeah, I'm just going to do it like this. For this buffer can be reused, I think, or can it? Log printf failed to read message from WebSocket error, and then we return and print this line. Okay, and then we can print we're just breaking here. Log print ln closing connection. And now since we are not handling the interrupt, we should not be catching it. So let's see. We connected, we are getting a message. And then we get another message. And another message, great. So I'm not going to listen to too many because they cost me money. But I think it's a good time to commit. Git add, git commit, and wait, no. I'm going to commit using JJ. So WebSocket listener example. Okay. And now we can try and integrate this client somewhere in the application. So let's say, also we don't need Gorilla for now, Go mod tidy. Okay, do we still have Gorilla in? Okay, we got rid of the Gorilla. And I think we can implement this in like in a lib directory. Yeah, I'm going to call this package exchange rates or something, or WS client, or yeah, I could call it a service, but then we could confuse it with a database service. But yeah, okay, I'm just going to call it WS client for now. Coin API, and then ws.go for WebSocket. And in here, I'm going to call this package Coin API, and then I'm going to define it as a type. So type Coin API WebSocket client, which is a struct. It has a token, which is a string, and that's going to be the API token. And then it's going to have How can I interrupt this actually? So I think if it runs in a Go subroutine, then in a Go routine, then if we return from main, it should also be closed. Can we somehow get, wait, this is coder WebSocket, we don't want this one, we want and no, we want another WebSocket, okay, no. We want this WebSocket, right? And so if a connection, and how does a select statement work? So okay, I think we can try and handle this in a I think we can okay, yeah, I think we can use this select statement even if we don't have a channel. So I'm going to create I'm going to implement a constructor, so new coin API WS client with token string, and returns a pointer to this coin API WS client. We return a client with a token, and then we're going to take this API endpoint, and you could probably just hard code it like so. Var API endpoint equals URL with a scheme of WSS host of this, and that should be it, I guess, and path maybe of root. Okay, and then a fake origin would be URL scheme HTTP host, localhost, because we are always listening from localhost. So we can then we could actually technically we just want to store the latest event, right? So we may need a mutex, probably. Go doc sync mutex. What do we have? There is an RW mutex. What's go doc RW mutex? So a reader-writer mutual exclusion lock. Arbitrary number of readers or a single writer. And what's okay. We don't really need to. Yeah, we just want the latest yeah, I'm just going to create, how do we initialize a mutex? The zero value for an RW mutex is an unlocked mutex. Okay, so I'm just going to call it sync mutex, and I'm going to just, yeah, I'm going to use the zero value, and then I'm going to define a method on this client, update rate. So the for now we can based on quote to reference. Okay, so type is exchange rate, rate is this. So yes, I'm not exactly sure if I'm happy about this JSON value. Because it can be this is like a very long number, and I'm not sure if this is going to be reliably represented by a float, but for now let's just screw it. Or maybe, you know, we can somehow get a decimal from it or something. Yeah, maybe I'm going to try I think there was a type called shop spring decimal. JSON deserialization. Yeah. Okay, I'm going to need this library, and then an exchange rate message is going to have the types, which is going to, okay. So type exchange rate event struct is going to have a time, which is a time.time, and it's going to have a rate, which is going to be a decimal, hopefully. If not, we're going to have to asset ID base is a string, and quote like so, and then the type, and the remaining I'm just going to ignore for now. And it's going to be a point, and the last event is going to be a pointer to this. And I think I'm going to use an RW mutex just in case. So I'm going to call it date last event. And I'm going to pass an event, which is going to be a pointer to an exchange rate event. And error, and we need to try okay, yeah, we want to lock it, and Yeah, okay, it does not return anything. Okay, lock and defer CMU unlock, and if C last event is nil or C last event time is after this new event, then we no, if it's before, right? Then we set the last event to the new event. Okay, and then func, it's another method, coin. Yeah, we want the latest rate, right? Get latest rate, and it's going to return a decimal and a boolean, and so it's going to return the latest value if it exists. Okay, this is a struct, I think, right? So yeah, we don't really need it. We can just CMU rlock defer CMU unlock, and then we return the, okay, we actually want to clone it, right? Can you copy something? Okay. Copy struct in Go. Okay. My event. Oh, actually, you know what? Value equals C event. If C last event is nil, return nil. Otherwise, we make a copy, because, you know, it's a struct. Is it? Okay. Yeah. We copy it inside this function, and then we return a pointer to it, like this. And then we may want to implement a starting routine or something. So start, it's going to return an error. And I think we're also going to need a mechanism to finish it, right? So this is going to be a channel of struct and of empty struct. So this is an empty struct and it's just a 0 byte. So we can just close this channel, and then it means it will just mean that we stopped it. So what we're going to do is ws main. Yeah, we can print it as debugging something, or API endpoint to string, and then we build a config, and the endpoint is going to be API endpoint, and then the token is going to be C token, like so, and then we probably also should store the connection on the client. So connection is going to be a WebSocket connection, like this, a pointer, and then connection error equals WebSocket dial config with this configuration. If there was an error, we return the error, otherwise we store this configure connection on the struct and return nil. And we can probably also create a channel, so make channel of structs like this, and then we how would we actually close this? This is an echo? No. So where is this done used? Okay, so what would happen if go doc close? So if I close a channel, does it mean channel buffering? Okay, and was there, no, okay. So channel synchronization. Channel directions, no, select. Timeouts. Yeah, okay, I'm just going to assume that it's somehow going to work. So I'm going to write another function called the loop, and it's actually just going to be looping, and it's going to be this loop. So for select, if we get something on the done, we can return, Wait, how does select work again? Case. This. Wait, what? Select case this. We return. And default is going to be message error equals C connection read, and we're going to take this buffer. So it's going to be a byte slice of the size 512, or maybe just 1 kilobyte is safer. And we're going to read it to the buffer. If there was an error, we print this message and return. And then we try to parse this we try to parse this message. So var payload is going to be of a type message. Wait, was it? I think we call it something like event, exchange rate event, error equals JSON on Marshall, message into the payload. If error is not nil, log printf failed to parse incoming message as JSON. Yeah, we print the message string payload. String message. Okay, no, we ignore this. It's buffer. And then we can return, and otherwise we can update last event with a pointer to. Okay, and in this update last event, we also don't need to do anything if the event is nil or the events. Yeah, the event may be nil, and that's all we return. Okay, that was a lot of code. I have no idea if it's going to work. We can also implement the method to stop it. Okay, so coin AP stop, and we just send to done, like so. And this should stop the loop, and then in here we can go see loop. Okay, and that may not go. We can try and implement this method. We can try and instantiate it, right? So WS client equals, do I have coin API something? Coin, where did I implement it? Coin API. Okay, coin API. new client with the API key, and error equals WS client start, and if error is not nil, log fatal error, and I'm going to pass this to the router. So I really just need a the latest exchange rate. So type exchange rate service interface, and it's going to have a method called get latest rate, which is going to return a decimal, and I'm going to call it RS, and it's going to be an exchange rate service, and in here I'm going to pass the WS client. And let's see if this works at all. Okay, so now in pages.temple, I'm going to stop it for now. In this page controller, I also want access to this interface, you know. So I'm also going to call it RS, and it's going to be an exchange rate service, and this is going to accept an exchange rate service, and I'm going to store it here, and then rate equals c.rs get latest rate, and then in pages index I'm going to store a current rate, which is a decimal. Okay, and I'm going to print it. So current rate, does it have like a string? Okay, let's see. Can I build it? No. In the router, and in the router, wait, why not? And in the router, I'm going to pass this client. So now take generate and build. Okay, go run. And now I got a beautiful invalid memory address. Okay, so I think I'm going to have to debug it. So did I even start listening, or WS client? So in this client, I'm just going to log all events, print ln. No, okay, I'm going to pass it like this. Okay. Are we getting events? Oh, you know what? Because we haven't subscribed. So we need to send a subscriber message like this. So yes, so like this and this, and if error equals connection write message, error is not nil, return error. So now if we run it, okay, invalid character after top level value. Incoming message as JSON. Okay, what if we try and parse it as a float? I don't really enjoy the idea of this being a float, but you know, float 64. Yeah. Now none of this is going to build because different. Okay, so in the router, this is going to return a pointer to a float 64, and then in page controller, okay, then this must be a pointer to a float 64, and then we can use strconf, or you know, we can just say if current rate is not nil, we strconf go doc strconf format float, or you know, I'm just going to use fmts printf I think it's an F current rate, else no data available. So now if I run it, okay, page controller, temple generate, go run. Okay. So what does this even mean? Okay. We need to know the actual size of this message. Not terribly surprising. So yes, number like this and like this, go run. Okay, and does this mean that maybe we don't need to, we can maybe use it as a decimal? Again, so I want this to be decimal, and the rate should be, oh wait, where are the events? This is a decimal, this is a decimal, and why does it complain about this? Okay. and then go run. It's going to fail, obviously. So in main.go, in the router, this should again return a decimal, and in pages template, this should take decimal, and then this should return current rate.string. Temple generate. Okay. So now if we go to localhost, we get these rates and we can see what they are updating in real time. And how much did I record? We are out more than an hour. So I'm going to stop for today. And I definitely, like depending on the reception of this video, I can definitely do another video about the REST API, because I have really enjoyed this one. So let me know in the comments if you didn't like something about this video, or if you have some more wishes. And if you like this video and if you learned something, please let me know what you liked in the comments, and maybe even like and subscribe. I know this is a cliche, but this really helps me with the algorithm. And I hope you learned something, and I will see you in the next video. Thank you.